Very good morning, Vice Rao sir. Dr. Vice Rao sir. Am I audible, sir?
Yes, sir. You're audible. Good morning. Good morning, all.
Good morning, sir. Good morning, sir. Sir, if you can present your screen and turn on your camera.
Yeah, yeah, sure.
Yes, sir. It's visible perfectly. Yeah. So you're perfectly audible as well as your screen is
Oh,
perfectly visible. Thank you so much, sir. And
so these
we'll
are,
start at yes, sir. Please.
yes, sir. They're all which standard? I mean, which class?
The students are from fourth semester as well as sixth semester.
Okay.
Uh, the sixth semester students have gone through the AVR as well as ARM, and fourth semester students
Uh,
are right now learning AVR.
Oh, great.
Yeah, and so we are also having one link, YouTube link. So if students are having query, they can interact through YouTube link also.
Okay.
So there are limited number of students right now in Microsoft Teams just because of some security
Mm-hmm.
issues.
Right, right.
So we'll start at 11, right?
Yeah, you're sure.
Okay. Students are requested to raise your hand in case of you are having any queries.
Hello, sir. Am I audible? Hello.
Yes, sir, you are
Yes, sir.
perfectly audible, sir. Yes, yes, yes.
Okay.
Okay, so
Thank you.
good morning, one and all. It is my sheer pleasure to introduce the guest today, who is an eminent personality into the field of robotics. I have been known him as a prolific reader and a sincere researcher and an honest man who married his vocation, that is academics. Also welcome our respected head of department electrical, Professor V.Y. Doshi, who has always been impetus for our academic growth. Thank you, sir, for your precious presence. May I request
Thank,
Professor V.Y. Doshi to say few words on this event, sir? Please, sir.
thank you, sir. राव साहब का मैं बड़े दिल से स्वागत करता हूँ. सभी फ्रेंड्स, सभी स्टूडेंट्स, सभी साथियों, सहयोगियों, सारे दूसरे डिपार्टमेंट के हेड, सभी का मैं स्वागत करता हूँ. मैं एक दिन का सिकंदर हूँ, यानी कि आज का एज अ प्रिंसिपल मुझे बुलाया गया है, तो उसके लिए बहुत बहुत धन्यवाद, है ना. और राव साहब का खास, क्योंकि देखो है ना, रोबोटिक्स या तो रोबो, है ना, ये शब्द बड़ा ही करप्ट हो चुका है। रोबो रोबो, लेकिन अब उसका क्या जरूरत है, क्या इम्पोर्टेंट है, वो एक बार टच हो जाए तो वो टेक्नोलॉजी सीखने का भी मन हो जाए, है ना। तो देखो, ये फोर्थ जनरेशन है। पहली जनरेशन थी पानी और स्टीम वाली, जिसे सब कुछ चलता था। दूसरी जनरेशन आई इलेक्ट्रिसिटी वाली, ओहो इलेक्ट्रिसिटी आ गई। तीसरी जनरेशन आई कंप्यूटर वाली, कंप्यूटर आ गए। और ये चौथी जनरेशन है आईओटी, रोबोटिक्स, आर्टिफिशियल इंटेलिजेंस, ये सारे के लिए, है ना। अब ये रोबोटिक्स क्या करेगा, है ना, क्यों हमें ये रोबोटिक्स चाहिए, उससे ये होगा, ये प्रॉब्लम होगा, अनएम्प्लॉयमेंट आ जाएगा, ये सारी बातें गलत है ना। जितना भी काम इंसान मशीन से करवा सकता है, उतना काम करवाना ही चाहिए, क्योंकि वी आर रनिंग आउट ऑफ टाइम। देखो, किसी के पास टाइम नहीं है ना। अगर टाइम हमारा कहीं पे भी बच जाता है, तो वही टाइम हम और कई जगह पे क्रिएटिवली यूज करके और आगे बढ़ सकते हैं, है ना। आज तक जो भी टेक्नोलॉजी में हमने डेवलप किया, तो क्या किया, ट्रांसपोर्टेशन डेवलप किया, फूड की अलग अलग नई नई टेक्नोलॉजी आ गई, हेल्थ की आ गई। लेकिन अभी तक हम डिसीजन इंसान ही लेता था, और इंसान का कोई ऑप्शन उसमें हो नहीं सकता। लेकिन इंसान जब डिसीजन लेता है, तो एक प्रॉब्लम क्या होता है, सपोज मैं अभी कुछ डिसीजन मुझे लेना है, तो बहुत सारे डेटा मेरे पास है, लेकिन सारे डेटा को मैं कनेक्ट करके एक आइडियल और सबसे बेस्ट डिसीजन में नहीं ले पाता, क्योंकि वो टाइम पे, रियल टाइम पे सारे डेटा मेरे पास होने के बावजूद भी मैं उसको कनेक्ट नहीं कर पाता, उसको इंटीग्रेट नहीं कर पाता। लेकिन अगर रोबोटिक्स पे हम जाते हैं, तो सारा डेटा हमने इंटीग्रेट किया है, पूरा उसको एक दूसरे के साथ जुड़ा हुआ है, और उसके बाद में वो डिसीजन लेता है। तो हो सकता है कि हमसे भी अच्छा डिसीजन वो, जो रूटीन बात है ना, जिसमें क्रिटिकल थिंकिंग नहीं चाहिए, वो सारी बातों में तो एटलीस्ट वो ले सकता है। तो रोबोटिक्स के बिना चलने वाला है नहीं, है ना। सबको आज नहीं तो कल रोबोटिक्स सीखना ही पड़ेगा। आज सीख लिया तो ठीक है, वरना कल सीखना पड़ेगा, कंपलसरी सीखना पड़ेगा। तो मेरी सबसे गुजारिश है कि बड़े अच्छे से ये लेक्चर को सुना जाए, समझा जाए, और बाद में जरूरत महसूस हुई तो सीखा भी जाए, है ना। तो अभी मैं ज्यादा नहीं बोलूंगा, है ना। फिर से एक बार राव साहब का धन्यवाद और सबका स्वागत। थैंक यू वेरी मच सर।
Thank you very much, Professor VY Dosi, for your kind words and, as usual, your ever showering blessings, sir. May I now request our dignitary, that is Dr. Y.S. Rao, sir, to take charge of this session. The session is yours, sir. Welcome again, sir.
Yeah. Can you see my screen now?
Yes, sir. Your screen is visible.
All right. So, good morning, Dr. V.Y. Joshi, head of the institute, and Dr. Kunjal, professor of electrical engineering department, and various faculty members, and my dear students. See, Joshi sir has is already mentioned about the significance or the purpose of this robotics. But then, my entire presentation is not specific to robot. It is in general about what is happening today about the software and hardware, and why it is so important in every branch of engineering. That's the whole topic is. And these are my associations. I was at IIT Bombay, and Dr. Sanjay Joshi was my colleague that time. And I used to come to Valsad, in fact, in 2011 as a consultant. So there is a solar company called Gadia Solar in Valsad. So later on it was named as a Plarium. So I was consultant there. So that was my connection. 2 years I used to come from Mumbai to Valsad. But majorly our role was automation, right? The solar tracking system was done under my team. That one thing. And we also started. I'm a vice principal and dean R&D from Sardar Patel Institute of Technology, Mumbai, Andheri. And Mtron Technology is my company, where we manufacture some educational kits or some industrial related products. And currently we are also started one Go Green Technologies for agriculture products. Also some meditation point of view. All right, so this is my just associations. This is what I was actually informed Dr. Joshi and Professor Kunjal, that we have come up with a activity-based learning. Small robot, one can build it. Professor has rightly mentioned that you are all people learning AVR microcontrollers in 4th semester and ARM in 6th semester. So the purpose of making this hardware is activity-based learning. That means even if you are at your home, wherever you are, practicing is at most important. And then whatever is the skill set required as a programming point of view, at least we are planning for 3 semesters training, level 1, level 2, level 3, 3 levels, right from basic level to advanced level like cloud-based applications or mobile-based applications, how to do it by using this EduRobo trainer kit. I personally wish that every student should have this in your, like, like electrical engineer, every one of you should have a multimeter. Similarly, at least you should have some hardware, right? Some programmable device, so that at least a good number of applications you can build it. Also, some mini projects or major projects you can do it. So what we believe is do it yourself. Unless you do it yourself, unless you practice, this engineering is of no use. This profession is of no use. Right, so it's a low cost. Hardly it will cost you 3,000 rupees. Instead of eating some junk food, you save that money and have this. We will train you 1.5 years free of cost. Every week there will be one session, 2-hour session, and there will be some assignment. You can do that. And even if you miss that session, we will give you the my recorded session. I will be teaching, and my own consultants who are working in industry, they will be teaching. So, so like that, at least 6 months, weekly, once 2 hours, if you spend, I'm sure at least you will have good programming skills and exposure to few technologies up to this Internet of Things, IoT applications. So that's the purpose of why I thought of informing you. So this is what level 1, level 2, level 3 is what we have decided. Okay, so just keep it aside about that EduRobo hardware product which you have made. Let's enjoy the talk, maybe another 45 minutes about this software and hardware. Joshi sir was rightly mentioning that 4 evolutions of the industry 1, 2, 3, 4. Right. So today 4th is we are talking about robotics, but then otherwise machines and automation is not new for us, right? We know, small crushing machines, right? Crane car AC motors, or maybe machine, isn't it? So I'm sure you might have heard about this, or I'm sure you not heard. You are using ATM machines, right? Or coffee vending machines, right? There actually you are doing the transaction, money transaction. So it is actually a computer, right? A computer is sitting because there is a operating system, and it is whatever is the currency you are either inserting or taking out. There is a lot of security issues. And then on top of it, there's a mechanical system which is counting your notes and throwing out. Look at how many fields it involves: electronics, mechanical, electrical, computer. Expertise of 4-5 fields are required to build one either vending machine or a ATM machine. So that is the complexity. Even if today's washing machine also, if you see, it's not a simple washing machine today. Today we talk about 6th sense washing machines. Air conditioner also, we say smart air conditioners are inverter based air conditioners, and so on. So even refrigerator, we say 6th sense. So even refrigerators are inverter based refrigerators, right? And they are inbuilt in these devices. So everybody is now this customer segment is expecting more and more smartness in the machines. So they are no more simple motor-based systems. Motors are there anyhow, but on top of it, there's a software and hardware. In short, we are what we call as a computerization. But then, today we are talking about not only just automation, we are talking about the smart devices. So where the smartness comes into picture, is your phone is smart, is your TV is smart, smart TV, smart fridge, smart AC. So the smartness of any system comes because of the sensors in it, right? For example, we are also talking about driverless car, right? A driverless car means imagine uh, uh, it has to sense the complete environment uh, before taking any action. How many sensors and how many directions, right? It has to sense while traveling. I mean, that's the most complex part of it. When you are actually moving at, let's say, 150 kilometer speed, and you have to take a decision by collecting the entire environment data, that is called real timeness, right? I hope you can understand what. If you don't take the decision in time, natural time, then it may be accident. Anything can happen. Okay, so that's the requirement of today's generation devices. We're talking about more and more sensors or more and more sophisticated algorithms inside these devices. That is where are we also named as a artificial intelligence, AI. But please remember, AI is not just a computer-based algorithm, or like you use MATLAB or some software where you run the AI algorithm on the computer. Absolutely no. AI is there in your refrigerator, washing machines, everywhere, right? Your two-wheelers, four-wheelers, even a battery charging system also, you want more smart charging systems. Battery management itself is a complex system, right? So that's the demand. Even your television is no more connected to your antennas. Your television is now connected to the data centers like Amazon, Netflix, G or whatever, no, those data centers. So that's the beauty of it, that now not only computerization of the objects, now we are saying they're all connected to internet, and then they have inbuilt the sensors in such a way that if you are feeling like a human being, like Alexa, you all know, right? Alexa is one of the example where in a natural language you are talking to the device and it is accepting your commands. Okay, so that's the just a brief introduction about the difference between automation and devices. Now, coming to the definition of a robot, right? We have a feeling is that robot means it should have a two legs, two hands, right? One head, something like that. I mean, it's not that, right? If you, I have a lot of videos, but you can also find out on the internet. Robot is not about looks like a human being. Okay, no, absolutely no. If you really see the industrial robot manufactured by ABB, right, such type of robots, if you see, you will find that even only just one hand is also a robot. By any chance, if you go to this automobile industry, entire two-wheelers, four-wheelers are manufactured by robots. Even these aeroplanes, right? If you see some videos, you can find the Boeing manufacturing is done completely by robots. Your mobile phones is completely manufactured by robots. Most of the electronic motherboards, daughter boards are completely manufactured by robots. So if you see these robots, have any legs or head or ears or nose or something like that. They have maybe the pick and place sort of a thing, like a hand adjustments, end effects. and it is doing that. So then when do you say, can I call my washing machine as a robot? Washing machine is not a robot. Air conditioner is not a robot. But then when do we say that it is a robot? Robot means it should have multi-functionality, right? Not one function. Just by changing the program where the same device is doing some multiple functions, if I am able to build that capacity into that by changing the end effects. Let's say, for example, in industry, what I will do, I am right now, I am drilling. Now, tomorrow, I will change the program and I will change the end effect. Now, it will, instead of drilling, it will start painting. It should start welding, or it should start fitting. It should start sweeping, cleaning, and so many things. Same robot can do by simply changing the program and changing the some end effects. So that kind of a multifunctionality, if you can bring it, then yes, it's not just automation. It is beyond that. That's why it's called robot. And then I have listed some points saying that does it have ability to think, means some sort of a intelligence inbuilt, right? I mean, humans are natural brain, but then if you are putting the brain that is artificially into the machine, then yes, then you can say it is a, I mean, more or equivalent to a robot, right? So those are the some abilities, right? Human capabilities. If you are trying to fit it into the machine, then yes, I mean, you can say it's a robot. But then sometimes you might have seen that robots looks like human being, right? Including the whole body shape, skin, speech, eyes, ears, everything they are trying to match with the human beings. They are called humanoids. There are some applications of humanoids also. One is for entertainment purpose, right? Other is for some maybe in restaurants or some or drug delivery systems in hospitals. So there they prefer the should looks like a human, so that like a familiarization of the things. But if you see the industrial robots are skeletons or typical mechanical gears or the metal sheets, metal rods, sort of a thing. So you can classify these robots into, it depends on your application. They could be in healthcare, they could be domestic, they could be in military, they could be in space, right? They could be in healthcare and so on, right? So at least there are 10 to 12 application areas are there where these robots are widely used. But then, as I repeatedly saying, that robot doesn't mean that the shape of the human should be there, not necessarily. Based on the application, they have those attachments or sometimes they may be standalone systems. Sometimes they are hydraulic systems or pneumatic systems, or they may be moving like a human being, or they may be moving on a wheels, or they're fixed on a table and doing the fix and place, and so on. So there are several possibilities out there. Okay. So in short, what I'm trying to say is that smartness and computerization of the objects is almost everywhere, every branch of engineering. So there is no branch, including agriculture, right? We are saying these objects are computerized. Okay, like water monitoring system, humidity monitoring system, greenhouses, and so on. It's a very big business. Now people are talking about hydrofarming. That means even you don't need to have a agriculture field. In your building itself, in the RCC building itself, you can grow the vegetables. Is possible by using these technologies. In short, it is a combination of software and hardware. It's everywhere. Okay, so this branch itself is interdisciplinary, right? Engineering and science. Unless you join together, you shake hands, it's very difficult. We are now, actually speaking, we have given less importance to science and we have given a lot of importance to engineering. That's the blunder the entire country has done. right? We have seen engineering, science as a passing subject. We are not given much importance, but that is what actually killing our innovations, right? Uh, because see, most of the inventions are happening outside, right? In other countries, we are only just importing the things, or maybe our service providers, not a designers, right? That's the problem. But actually, applications of science is engineering. So my appeal once again is we should give a equal importance to science. Then only you can come up with a great ideas or multidisciplinary applications. All right. So now we are going to finish 75 years of independence, and during this period, right, in 75 years, we have achieved so many things. Almost every state has a IITs, and every district has NITs, and 12 lakhs, more than 12 lakhs are getting passed out, 10,000 engineering colleges, 4,000 diploma colleges, and so on. So good bandwidth we have, but still, if it comes to research, or when it comes to contributing to the uh, industry, it's very less, right? We know Japan, we know Korea, we know China, right? These are the countries which have uh, uh, proved to the entire world that they have the manufacturing capability to other countries. India is only so far is taken care of domestic needs, but now after post-COVID, the whole world is expecting India to go for manufacturing for other countries. Okay, so I know this year also you might have seen the budget. Government of India budget, they are mainly allocated for this electronic semiconductor industry. Like Tata Industries is also investing a huge amount of money in IC manufacturing and so on. Okay, so if I develop any product, right? So I have done some product. What is the outcome, right? Is it some award somebody will give, some publication I will do, something like that, or am I converting my whatever the project you are doing into some business model, right? Your whatever the product whatever is the project you are developing, don't think that it is just for scoring marks or no term work point of view. Just think that it is a product where you can commercialize it. I'm sure in Gujarat also several companies are there. I have Surat also, there are several institutes. I have been to Anand also. There are a good number of institutes. So like that, a lot of government colleges also having this facility of converting your project into product, and making a patent, and starting an incubation center. Right. So that is the beauty of it. Now you have to think differently. Lot of gray areas are there. Like battery charging itself is a very big area, because electrical vehicles are going to be everywhere in coming 1 or 2 years. But then the most challenging part even today in electrical vehicle is battery and charging. So what is the challenge there? That you can do the survey, that why lithium ion is still a problem, because lithium ion is not there in India. So that's why even if you develop the technology, but you are not going to contribute to in Indian perspective, because we do not have lithium ion. Again, we will have a problem. Today, 80% of the fuel we are importing. Same thing will happen in lithium ion also, because we do not have lithium ion. So that's why your projects, your research should contribute to the country or the society. So you should do on a different materials, not lithium ion or not lead acid, right? There are some thorium or some other storage elements. Okay. So expectations and reality always, there's a mismatch that you need to understand, that what customer wants is something else, and what this manufacturing takes place is something else. Let's say customer want one small jeweler, right? Hanging tire. but it is less understood, and then the way it is presented, people will make salesperson will project something, or manager will project something, designer will project something, and so on. So that is what is the problem in the reality versus expectation. Probably this is most commonly you will face every day. Whenever you buy a coconut, there are two types of coconuts. In one coconut, you look exclusively for water. In other coconut, you look for exclusively for that fruit. But in both, most of the times we are surprised. In when you buy this green one, you want more water. But when you open it, you may find more fruit. Or this brown one, where you want to make some chutney or something. But when you find there's a less fruit and more water. The same thing happens in the industry also. What customer wants, what the money you are paying, and what you are getting is always a mismatch. That's where the industry fails. Okay, so all engineering students, please remember one thing, the first law of thermodynamics. The first law of thermodynamics says that energy is conserved. It cannot be created or destroyed. Okay. So if you remember this first law of thermodynamics lifelong, then you develop any project, right? Any kind of research you do it. After that, what you claim is that I have improved the efficiency, I have reduced the size, or it is consuming less power, less cost, right? And so on. You will make several claims. But then the problem is, whenever you are saying you have improved the efficiency or reduced the size or something, please remember, somewhere you have compromised. That is the problem. When you compromise, right, then there will be a problem. Everything cannot be improved. You have compromised on some parameters and you have improved some other parameters, or you have assumed some parameters and you have worked or developed on some other parameters. So that's the problem. Reality in products, you cannot make assumptions, right? Or you cannot only improve one parameter and neglect other parameters. You cannot do that. Let's say, for example, in this COVID pandemic situation, few companies came up with some medicines for COVID, right, to kill the virus. But in reality, what has happened? The more number of deaths has happened after taking these drugs. That's the reality. Because though this drug might have cured the that virus, but it has affected the organs. Some kidneys are failed, liver is failed, heart is failed, lungs are failed, and so on. So this is a problem. You are saying, oh, my drug is very effective, it's efficient, and this and that, but that's okay. But that means you are talking about only one parameter. You are the side effects. So that's why I am saying that in engineering or in product design or in research, it doesn't work, because finally it is your whatever you are doing, what is the outcome of it is you want to really make a product out of it. So there you have to worry about all the characteristics, complete all-round performance, not only one or two parameters. Okay, so every product or research has some characteristics. Good product has some good characteristics. So one is the quality, undoubtedly, the cost, how much time you took for development, and development cost and development capability. See, in spite of you are having right, your brain and product in hand, everything is okay, but you also should worry about the development capability. Let's say, for example, today in India, there is no company who is manufacturing integrated circuits. ICs, they are not manufactured in India. So that's what I'm saying. Capability. So we do not have the capability to manufacture the ICs. But in China, if you go, there may be some 400 IC manufacturers are there. Taiwan, you go, several companies are there who are manufacturing ICs. Even small countries like Philippines also manufacturing the ICs. But why not India? So that's where you need to understand that capability is different. It's not about the cost or size or something else. Also, you should have that, the infrastructure ready to manufacture such type of products. Okay, so every product, every technology has its own life cycle. So there will be a time period where your product will make some profits, but then again the sales will come down. So in the life of the product, there is nothing like a constant DC line. Okay, as you can see, it is like a Gaussian curve where slowly it will pick up. It will be there for a shorter period. Again, it will fall down, right? You know what happened to Nokia phone. Nokia is the first company who manufactured the mobile with 80% market share. Today, Nokia is not there in the market, right? It's not a big market. Similarly, BlackBerry phone. BlackBerry was doing good business in the industry. All corporate people were using BlackBerry phones. Today, nobody is buying BlackBerry phone. The market share is very, very nominal. So like that, IC manufacturing, for example, Intel. Intel is a leading company for making the CPUs, but nobody is buying Intel CPUs other than your that computer i3, i5, i7. Your mobile doesn't have Intel CPU. So name any product which has Intel CPU. Very, very rare. So the same thing. If your research, if you don't do it quickly, and if you don't make the profits, and again you don't reinvest, then you are dead. Lifelong, you cannot make business, right? Lifelong, you cannot make profits. It has its own life cycle. So just remember that. These are some technologies which are obsolete in these last 5 to 10 years, right? You know, CRT tubes, floppies, Symbian operating system, Nokia, I was telling, 80% of the mobiles were having Symbian operating system. But today, where is Symbian? Everybody is using Android as an operating system. And government of India is also recognizing now Bitcoins. That means in future, there is no paper-based currency. It is less currency. And so on. Kodak cameras were popular for several years. But today, where is Kodak, that film-loaded cameras? It's obsolete. With filament is obsolete. DVD or CD players, that cassette-based, is obsolete. So that's the problem, right? This generation, or particularly your generation, is quickly getting obsolete. So that means by the time you finish your degree, whatever your study is also obsolete, as far as technology is concerned, not fundamentals. Okay, so these are all called disruptive technologies. Just remember, like Dr. Joshi has mentioned rightly, that these technologies will be there only for a shorter period of time, but then they make a lot of disturbance in the market, right? Some industry will make a lot of margins, other industry may collapse, right? Today we have 3D printers, right? Today we have robots, we have cloud-based technologies, renewable energy, and so on. So internet, 5G is coming. So these are all disruptions is happening in the industry. Somebody is making business, but somebody else is getting suffered. That's the problem with these disruptive technologies. And these are all predicted by the industrial research organizations. Okay. So whenever you have a disruptive technology, the growth is not linear. It's non-linear. It may be exponential in nature. So just keep it in mind. For a shorter period of time only, it will be there. Again, it will vanish. If you are interested in finding which technologies are having a huge demand, you can find out on internet also. You can type Gartner hypercycle. I purposefully kept 2019 and 2000 because 2019, if you see the expectations, the technologies, they are 5G, artificial intelligence, edge computing, something like that. But in 2020, this hypercycle expectations are exactly opposite, completely changed. Nobody is talking about IoT and all that. 5G is also nobody is talking. But what people are talking is healthcare sector. You know how many countries have hugely invested in healthcare sector during this COVID period. Now also it is happening during lockdown. What kind of this countries are facing now? Also China is facing, Malaysia is facing, Singapore is facing. So some of the South Asian countries are still facing this COVID situation. So I was telling you that, yeah. So it's finally, just remember, it's because of this combination of science and technology. It is possible to have a great inventions. Okay, for example, 2014, these three scientists, Japanese scientists, right? Isamu, Hiroshi, and Shuji. They are physics scientists. The physics scientists, they have invented one light called a blue LED. They have invented. Earlier, there was no blue LED. So since red, green is already there, and with the help of blue, now white LED is invented. What's the advantage of white LED? Now you don't need to use the filament-based bulbs. Okay. What is the drawback of filament-based bulb? Lot of energy is wasted, right? Lot of energy is converted to heat, not as a light. So that's where this LED came into picture, white LED, and now it's doing excellent job. Excellent in the sense the entire power sector is saving the power 30-40%. That's the beauty. When one has saved huge amount of power. Of course, the pollution, carbon, all these things. So that's why I said outcome-based research means, have you contributed something, even some small fraction, to your son, your country, or to your institute, or to your own, whatever. So always have some objective towards the research. Why do you want to do the research? Not for some other country's progress. Okay, so gaps will be always there. You do anything, gaps will be there. Today, we are talking about a data science, but then the entire 4 years of engineering, if you doesn't have data from where it is coming, then what is the use of data science? Communication is another issue. For example, through robot, you are performing some operation, but then if there is a failure in the communication link, then how remotely the doctor can perform the operation? So reliability an issue. Then computation, right? Today computational devices, whatever they're having abilities, is still not sufficient. The expectation from a human is that behavior of a human, that means brain. You want the human brain to be put in the CPUs. So you will find a good number of articles on it, how to put the human behavior into the ICs. Okay. Driverless car, when I was talking, look at the complexity part of it. The complexity part is that what extent it has that kind of a driverless. So, in short, it should replace the human beings. A driverless car should replace the human beings. But then it has failed, right? Google has failed, Microsoft has failed, Tesla has failed. These companies have failed making full automation. That's why I said gaps are always there. So then what they have done, people have classified now these driverless cars as a level 1, level 2, level 3, level 4, level 5. What extent they are autonomous, what extent they are assisting the driver, accordingly they are classified. Driver 1, level 1, 2, 3, 4, 5. Level 1 means just a driver assistance. Level 2 means partial but automation. Level 3 means conditional automation. Level 4 actually high automation and full automation. So a lot of expertise required, undoubtedly. That's why some of the companies are merging now, right? Because see, they do not have the or financial problems. So they are merging. 2, 3 companies are combinedly developing these technologies, but it takes its own time. A lot of research is involved in that. Similarly, the drones. I know government of India is also announced that drones manufacturing in India or maybe the detection systems, because from the borders the drones are crossing and they're bringing some arms or some drugs. That's another issue. So government is badly looking for in this sector also huge investments. So as I told you, robot doesn't mean that it should look like a human being. Not necessary. If you are spending, for example, space robots, it doesn't have even legs. It's, yeah. सर ने बोला सिखाओ करके एक स्टूडेंट को बोला था लेकिन बाकी लोगों को ले लूं क्या ट्रांसफॉर्मेशन सेशन लेके अच्छा आप है क्या आई डिडंट नो नहीं मैं वो हां ले लो आप हां यस all right, so yeah, so see, the robots are not always having the same capabilities. The robots used in space has a different kind of environment. And I was telling about industrial robots, military robots, and the robots are used in healthcare sector. So, but then when you are saying robot, it has some abilities like a human thinking, right? The way we write the coding in air conditioners, refrigerator might not be that complex, but the way we write the coding in robots, I mean, millions and millions of lines is written. Okay, so I think I was just continuously speaking. Let me play maybe one small video, then you will enjoy what I was talking about, the smartness in the robot. Hello.
Yes, sir.
Can you see the video? Just now I was playing.
Yeah. So actually, still it is showing the PPT of or of one
Yeah.
picture that is
I
Mars
know.
mission.
I should stop. I think I should stop sharing. Again, open tray. Yeah. Okay. Now can you see this video?
Yes, sir. Now it's visible.
All right. Yeah. I hope now you can understand. What I was telling is that it's not. It should, looks like a human or whatever. It's based on the application. Accordingly, we choose the actuators, we choose the motors, we CPU, and so on. It's a custom design thing. So it's a debatable thing. We should look at various aspects of these things: cost, size, weight, scalability, reliability, and so on. So, in conclusion, just remember one thing: technology is a choice, and you have to look at various aspects: performance, cost, power consumption, and so on, time to market, of course. So either you can completely design by CPUs, or you can completely design by FPGAs or ASICs. It's a choice, basically. It depends on who is the customer and what is the requirements of the customer. So Mumbai at Sardar Patel Institute of Technology, Bharati Vidya Bhavans is, in Andheri. It's a nice campus given by Munshiji, Kanhailal Munshiji and Sardar Vallabhbhai Patel. It's a 50 acres campus. We also have a technology business incubation center. So any engineering college in India any student can come to this place and see the facilities, use the facilities, apply for a grant if you have a very good idea. And if your idea is can be given. So that is one facility we have. Similarly, we have another facility called Product Development Center. That's what I was telling you, this product, right? EduRobo, the small robot, you can build it at your house itself. And then, you can program it in such a way that a complicated programs can be developed. And that we will be training free of cost. So, at least 1.5 years, up to the level of IoT based platforms. These are some new products which we have developed in the Product Development Center, so that you don't need to have a CRO, power supply, function generator. All of them are inbuilt by some integrated circuits. So if sitting in your house itself, at least 4 or 5 subjects, practicals, you can do it. Every subject, 10, 12 practicals. Like that, 4 or 5 subjects we can target. Similarly, IoT and embedded system also, right? Like AC motors, DC motors, various peripherals, all of them servo motors. You can interface them to this board. At least 2, 3 subjects, IoT and all, you can do the practicals. So these are all some from our side. Just to brief you, we also provide some internships at SPIT. It's open to all, maybe some through proper channel if you apply. And if you are selected, you can work on our ongoing projects. Okay, so finally, just to conclude, so this is the EduRobo I was telling, a low cost, approximately 3,000 rupees worth hardware, which has the ability of Bluetooth, Wi-Fi, motors, controller, LCD, and so on. And of course, that infrared based TV remote control and so on. Which is mainly meant for activity-based learning, so that we believe do it yourself. If you do it, then only you will get the confidence. Today, the biggest challenge is jobs are there, but people are not employable because you are not having that kind. Engineering is not a degree. Engineering is a profession. So professional means unless you have that capabilities, abilities, then no, then there's a problem of employability. So my appeal to all of you is that programming languages, hardware, it's not just a practical or it's not a term work. It is a profession, right? It's a profession. You should have a full proficiency on these languages and the hardware testing. Then you have a beautiful life in your profession. Okay, so we also, you can say, the small intelligence into the system. So the videos, generally I record my sessions on some products. They are there on YouTube. The channel is Mtron Technologies. So maybe you can go through a few videos if it is interested for your whichever is the subjects you are studying. Okay, sir. Kunjal sir and Dr. Joshi, I am done. These are all some products which were developed in the past. So I will mail my details to Professor Kunjal. Those students who just go through that registration form if you are interested. And my contact number is also there. You can call me if you have any doubts. But the session will be just weekly once on Saturday. But even if you miss it, we will share you the recorded so that you can complete the tutorial. Yeah, that's all from my side. Now the session is open for the questions.
Thank you so much, Dr. Rao sir. And
Yeah.
if students are having any query, they can ask. So one doubt from my end, sir. Uh, so how we can convert that Gaussian curves about the product the sustainability into exponentials, sir? Because as you said that Nokia or any product may have some stipulated time, like it will if market is demanding it may work for like a Gaussian curve. But what are the strategies or how we can convert that Gaussian into some exponential kind of or DC kind of curve, sir?
No, what happens is, see, technology, uh, at least other branches like mechanical, civil, some extent, no, this uh, production, there is no disruptions there, right? It's a linear growth. But this technology based things, right? Uh, Computer and now you yourself have seen data science, AI, ML, how many branches are mushrooming like that. This is all because their obsolete is very fast, right? I mean, hardly, for example, the integration is happening double the integration is happening almost every less than a year. The integration double is happening. So you have to keep it in mind that uh, see, it's not that you only working on the technology. The entire world is working on the technology. So then what happens is there are several aspects. I was just telling manufacturing ability, capabilities, time to market, cost, all these aspects one has to keep it in mind. But nobody can be a master of all these things. So that's why let us not involve in everything, right? You just focus only one part of your entire system, and the rest of the product you can get it done. For example, you do not have robots for manufacturing. That's okay. You can outsource it. You do not have the capabilities for PCB design. That's okay. You can outsource it. But what is your key is that your idea. That idea you should have, no, you should be quickly convert into prototyping and convert into product. But marketing also you don't need to do. There are some other agencies which are there in the digital marketing and so on, or at least do the technology transfer, or first do the patenting first, like that, because the whole business is around your idea. I think you have enough stories, right? For example, Uber, Ola, Amazon, they do not have their own products. YouTube, there is no product. Or your WhatsApp, there is no product. So these are the public contents. WhatsApp contents are public contents. YouTube contents are public contents. Facebook contents are public contents. But they are the richest people in the world. So what made them richest is because just an idea. It's not that they have built everything on their own. So, no, idea is very important. Immediately, if your idea has a commercialization, patent it immediately. Rest of the things, please take help of the ecosystem. Right? There are several companies are there who are willing to help you out.
Thank you very much, sir. And so another doubt is uh, what's the future of integrating the hardware, or that is let's be specific about IoT and data science. If we can sense the data, right, through of our real world, and we can collect all those data at some place, and then after using data science or using machine learning, we can, if we can do something which can be helpful to the society, sir. How about that integration, sir? IoT and machine learning, and
Actually speaking, no, this government of India is also came up with the educational policy NEP 2020. So now what is happening is, if your degree, for example, 4 years of engineering, or 3 years of diploma, or 2 years of ITIs, or 4 or 5 years of PhDs, 2 years of MTechs. Today, unfortunately, there is no difference between BTech, MTech, or PhD. I mean, that's a problem. Even if you study a computer science by BSc people, computer science by engineering people, a difference. Or IT by engineering people, IT by BSc people, there is no difference. Electronics by MSc people, electronics by engineering people, difference. This is the problem. Literally, this has killed the entire education. Because see, the expectations are different. Engineering, from as an engineer, when you are doing some degree 4 years, the expectation is creativeness, and that is the expectation, right? You cannot be just a data entry operator, or just only data conversion or data testing. Then वो तो डिप्लोमा वाला भी कर सकता है, BSc वाला भी कर सकता है, MCA वाला भी कर सकता है. So ये जो, when you are saying data science, IoT and all, every area has some expectations. As far as engineers are concerned, they are supposed to be creators, if not inventors, but at least the creators or developers. वो abilities जब तक नहीं रहेगा वो कैंडिडेट में, अगर समझो मैं डेटा साइंस पढ़ा रहा हूँ, लेकिन मुझे खुद मालूम नहीं है कि डेटा कहाँ से आ रहा है, राइट? मुझे मालूम नहीं वो हार्डवेयर क्या होता है, मुझे मालूम नहीं सेंसर्स क्या होता है. That means again you are becoming like a ITI fellow or a diploma fellow. You are not an engineer. So ये जो assumptions हम लोग करते हैं, फिर then you will become a handicapped. Then there is no difference between diploma and degree, or data science or computer science. Yes, sir. I mean, am I able to answer you?
Yes, definitely. So students or any faculty, those who are having queries, I'm parallelly checking the YouTube link. Those students who are watching this live session, please, if you are having any query, you're having half minute to throw your query. Any faculty or any students, if you are having any query, you can ask. So I think there is no query from student as well as faculty. So I would like to thank Dr. Y.S. Rao sir, for your valuable time and such a mesmerizing session, sir. So, lots of things that I was not aware of, as well as students were not aware of. That is Gartner hype cycle and this robo video, and what it taught about that activity based learning. It matters a lot for your overall development. And the quote that you said, sir, that it's not only the practical, uh, it's let's consider it as your profession, and then you will get the result for sure. So, sir, thank you so much for this amazing session. And due to the heavy work session from principal sir, and he told me to give their highs to you, sir. Thank you so much for your valuable time.
Yeah, it's my pleasure.
Thank you so much,
thank
sir.
You. Thank you.
Yes, sir. We'll meet sure in the next upcoming webinar, sir. Thank you, sir. Thank
Okay,
you.
then. Yeah.
Thank you.
Bye.
Thank you. Bye bye.